Okay guys, so today we're going to talk about function review as our first unit. And so we're going to start off with some pretty important definitions here. Specifically, we're going to talk about domain and range to start. Okay, so the domain of a function has to do with all possible values we can plug in to our function, called the input. And this is usually when we're using equations with x and y. X is usually our input, y is the output. Okay, so our domain are usually the possible x values. Okay. The variable x, or input variable, whatever it may be, is called the independent variable. We get to pick it independently. Okay. Next is called the range. The range has to do with all possible output values. So this usually has to do with y, or in function notation, f of x values. So this is the values we get back out of our function when we plug into values for x. Okay, so this is usually our y's here. That variable is called the dependent variable. Its value depends on what we plugged in for the independent variable. What we plugged in for x determines what we get back for y. Okay, so a relation is an equation or inequality that has two or more variables. So some easy examples might be like an equation of a line, y equals 2x plus 4. It could be something a little more complex, where we have multiple variables, y equals 2 times x times y. Well, not y, sorry. 2 times x times z, etc., where we have more than one variable, but there is a relation defined between x, z, and y, that y is equal to double the x and z multiplied together, etc. So a relation, it has to be an equation. It could also be an inequality, like y is always less than 2x, etc. Okay, so this would be a relation. Okay, more importantly, what we're talking about in this chapter is functions. Okay, a function is a specific relation where each input x has exactly one output y. Okay, so in other words, all functions are relations, but not all relations will qualify as a function. So what does this mean? A specific relation where for each input there is exactly one output. Okay, so this is a little bit of a side note here, but hopefully this helps show you the difference between these two. So let's pretend, I don't know, you're looking at a menu board. Let's say you went to the Thomas and Mack and you're at a Rebels basketball game, and you're hungry or thirsty, and you go up and you take a look at the menu. And we're used to seeing menu boards kind of take this shape, where we have our items on the left and prices on the right. We're going to also think of this as kind of the same way you would write maybe some coordinate points. So you could have, this be your x coordinate, comma, this be your y coordinate. Okay. Okay, so let's say we're taking a look at a menu board. And you can think of this as kind of being like, you go to a baseball game or something and you want to order some items and their prices are over to the side. So we've got hamburger, $5, hot dog, $4, large drink, 4, soft pretzel, 3, right? You can also think of this order as kind of mimicking the way we write ordered pairs or coordinate points when we're graphing, x comma y. So our items here has to do with x and our prices have to do with y. Okay, so when we look at this menu board, is it okay that hot dogs and large drinks both happen to be $4? That seems okay, right? I mean, it's okay for multiple items to happen to be the same price. And so what we can take away from this for functions is that repeated y values, so having 4 twice, is okay. And in fact, each of these different items all have one specific price, so this qualifies as a function. Okay, so this is a function. Okay, let's take a look at a second one. Okay, so here's a different menu board. It's pretty much the same, except down below we've now added hamburger again with a second price, $4 rather than $5. Is it okay for them to be charging some people $5 for a hamburger and some people $4 for a hamburger for the same exact item? No, right? We'd say something's not functioning there. And in fact, for this one single input, the same input of hamburger, we have two different outputs, two different y values. This is not a function. Okay, so for any given item or input, there should only be exactly one output. So let's take a look at one last example here. So this time our menu board, everything is the same all the way down to here, but I've added hamburger on again. But this time, hamburger matches the same price as above. They are both $5. Is that okay? I mean, obviously it seems kind of unnecessary to have it listed on there twice, and that is true. This is an unnecessary relisting of the same exact item and the same exact price. But would that be okay other than it being unnecessary? And the answer is yes. Okay, so if you do have a repeated X value or X item, if the Y values are exactly the same, it's okay. That would still qualify as a function. We've just listed the same value or same point on our graph twice. That would technically be okay. Okay, so let's use hopefully our new understanding of what a function is here to determine if each relation shown in a table is a function or if it qualifies as a function. Okay, so in our first example, we have our x's and y's listed vertically. You can think of these as our coordinate points, 2, 3, 2, 4, 3, 6, etc. You can also think of this, as we just talked about with our menu board, as x's being our items and y being the prices. Okay, so the first thing I notice on our menu board here is we do have the same item listed twice. Positive 2 is listed twice. Does it have the same price? And the answer is no. Right? We have two different prices for the same item. This is not a function. Specifically because we have that repeat, right? The x value of 2 has two different outputs, not a function. Okay, let's add another example in here. Oops. Okay, so let's use our newfound understanding of what a function is and isn't and determine if each here is one. Okay, so let's determine if each relation shown in a table is a function with hopefully our new understanding of what a function is and isn't. So as we look at this, remember that x comma y, you can think of these as just like the same way we'd write ordered pairs if we were graphing points. And again, we can think of this kind of like that menu board we were just talking about, where x's relate to our items and y relates to our prices. Okay, so is this a function or not? And the first thing I notice about this is our input value of 2. We have the same item listed twice here, 2 and 2, and it has two different prices. Is that okay? Would this be a function? No, this is not a function. Excuse my N's looking like H's. Okay, not a function. Okay, let's try another example. See if we can use the same idea. Here's another table, again listed vertically with our items on the left, prices on the right. Would this qualify as a function? Now notice that all of our items are the same price. You know, if we're thinking in terms of dollars, they're all $4. Is it okay that all of these different items happen to be the same price? Kind of like drinks and hot dogs were both $4. Yes, this is a function. Remember that repeated y values are okay, but the same item can't have two different prices. Okay, our last example here in this section, again, we can see we've got some items down here, and I do, once again, see this repeated item. However, it has the same price. Is that okay, other than it being an unnecessary repeat? Yes, this is also a function. Okay, so a red flag is repeated x values, but we need to check if the y values match, it's okay. If they're different, not okay, not a function. Okay, a visual way to determine whether or not something is a function or not. A visual way to test if a graph is a function, it qualifies as a function, is something called the vertical line test. Okay, it says if any possibly drawn vertical line a visual way to test if a graph is a function is called the vertical line test. The vertical line test says if any possibly drawn vertical line intersects a graph at most one time, so it won't intersect more than once, it'll only intersect once or no times at any value, then we'd say it passes the vertical line test and is a function. For that given x value, where that vertical line would be, it's only touching our graph once. It only has one price, okay, or one output. So let's take a look at some examples here. Okay, so determine if each graph passes or fails the vertical line test, and if it is or isn't a function. Okay, so here's our first graph. We've got this nice curving polynomial here. So imagine you were drawing in a straight line. So if you drew in some sort of straight line, and we look for where that line intersects my graph. So it looks like it's intersecting my graph right here, this one point. That's where it's intersecting that curve. Now imagine if I were to be able to grab that line and move it left to right. Okay, you could probably tell, sorry for some of the editing here. But anywhere I move this line, it's only going to be touching my graph once. Okay, so if that's true, we only have one output for any x value, for any input. This would pass our vertical line test. So in this case, we would say this passes the vertical line test. It's only touching at most one time, and therefore it is a function. Passes the vertical line test and is a function. Okay, let's look at a second example here. Okay, so here's our second example. Again, if we were to try to draw in some form of a vertical line somewhere, so you can pick anywhere you'd like, but if we were going to draw in that vertical line, is it possible to have it intersect our graph more than once? And hopefully you can tell on this ellipse or oval here that yes, that vertical line is intersecting twice. So for this given x value, 1 point whatever this is, there are two different y values. There's two different prices for this item. So you can think of this as x being our items, y being our prices. For that particular item, there are two different prices. This is not a function. So we'd say this fails the vertical line test and is not a function. Okay, so if we have a graph, this is the nice visual way of testing whether something is a function or not. For any given x, for any vertical line that we could draw in anywhere, it should only intersect at most one time. There should be just one individual price. Okay, in our next section here, we're going to talk about evaluating functions, so finding the value of a function. Make sure that we're always using parentheses when we do substitution, and of course follow order of operations once we're trying to simplify. So first thing to remember is when you see f of x, this is really the same thing as y. I mean, we could have given you this, y equals 3x minus 5. It means essentially the same thing. This is just notation to tell us that this is a function. It's called function notation. So it's asking us to find the value of f of negative 2. So what do you suppose that means? You could go back most basically and think about, well, here it says f of x, here it says f of negative 2. I no longer see x, instead they put negative 2, so it's giving you a good hint there that we want to replace x in our function with negative 2. This is the value to input into our function. So plug in negative 2 for x and basically find the value of y, find the value we would get. So this is the way we could notate it. F of negative 2 equals 3 times negative 2 minus 5. So again, make sure you're using parentheses when you substitute in. So 3 times x, 3 times negative 2. And we're not going to do any math here on the left. That was just notation to tell anybody what we're doing. All the math we're going to do is on the right. So we're going to multiply 3 times negative 2. Remember to multiply before you add or subtract in your PEMDAS. And then subtract 5. So we get negative 6 minus 5 more gives us negative 11. So when we plug in negative 2 into our function, we plug in negative 2 for x, we get back negative 11. And in fact, we know even on the graph, if I plug in negative 2 for x, we get negative 11 back for y. But this is the value, you have to excuse my box here, this is the value of our function. This would be the answer, negative 11. We plug in negative 2, we get negative 11 back. Now let's take a look at a second example here. Slightly more complicated, but same idea, so hopefully this will go a little faster. For this particular function f of x, plug in -5. So again, if we're notating on the left here, just to make our work look a little bit nicer, we need to do -2 times, again, parentheses here, -5 squared plus 3. Again, we're replacing x here with -5. Make sure we use parentheses. So now order of operations is a little more difficult. I can't simplify inside parentheses, but we have an exponent we need to evaluate first. -5 times -5 times itself twice. Positive 25. Okay, multiplying is our next one before we add. -2 times 25 is -50. And then finally we can add or subtract here. -50 and positive 3 gives us -47. So again, when we plug in -5 for x into this function, we get back -47 for y. So if we were graphing, we know this point would be somewhere on my graph. Left 5, down 47. These are x and y values. Again, the points you don't need to write as your answer. That's just stressing what this really means. -47 is the answer we're looking for here. Okay, so what if they wanted us to plug in, say, a variable or an expression into our function? Okay, so for this next example, if f of x is -5x minus 2, find f of a plus 2. Okay, so we're just going to follow the same idea, that where x is 5 times x minus 2, instead of replacing it with a number, we're just going to plug in this whole expression. We're going to plug in, and again, remember, use parentheses, a plus 2. So we do have some simplifying to do. We'll distribute our 5, multiply it through. So it gives us, sorry, -5. -5a, -5 times 2 is -10. And then we have a couple constants at the end we can simplify. We end up with -12. -5a minus 12. Okay, terrible box, but hopefully you get the idea there. Okay, there's our final answer for that. Okay, a couple easier questions. Translate the following statements into coordinate points. Okay, well, what's our input here? What would we use for x? Well, we plugged in 5, so there's my input value. And we got back out -12 from whatever this function is. So our coordinate point would be 5, -12. We plugged in 5, got back -12. So of course, for example 10, some function h, we don't know what it is, but we know when we plug in -2 for x, we get back 0 for y. So our coordinate point we can infer from that is -2, 0. Okay, our next example says, given this graph of h of x, so here's our function h of x, this nice curve, find h of -2. Okay, so they didn't give me an actual function to plug into, but I have to remember this is talking about x, the value we're plugging in, and its value, what we get back out, will be y. So we can think of the x and y coordinate on our graph. So let's go over to where x, remember x is the horizontal axis, where x is -2. So here's the x value -2 on the grid, and where it actually crosses our graph is down here. So I don't know a whole lot about this function h, but I know when x is -2, it looks like my corresponding y value is -1. So our answer there should be -1. When x is -2, our output is -1. So let's use that same idea for 3. When x is 3, so again, our input or x value is 3, we're coming way over here. What is my y value? It looks like my graph is pretty high up here. Looks like maybe it just intersects at the edge of the graph, and I can see that corresponding y value is +6. Plug in 3 for x, it's an x. We get 6 back for y, so our output is 6. Okay, lastly it says find x when h of x, remember this is the same thing as y, is -1. So they're changing it up. They changed the question on us. Find the value of x, or values, because sometimes it's more than one, when y is -1. So I'm going to use a line tool for this. So we're going to come down to y is -1, that's right here. And I'm going to draw a line where y is -1. There we go. Okay, so this is the line where y is always -1. So what are the x or x values that correspond on our graph? And it looks like, you can see it actually crosses 3 different times here, so we might have 3 values for x. We're just going to list them with commas in between. So what are some of the x values that give me a y value of -1? Well, we have -2. I actually got that from a question earlier. We also had the x value here is 0. Right, so that's an x value of 0, an x value of -2, and we have an x value of +2. So 0 and 2. So actually 3 different values of x give us an output of -1. So if it's asking you to find x, and it's giving you a y coordinate, that's a horizontal line. Where does that intersect my graph? And if it's asking you to find y, giving an input or an x value, that's like a vertical line. Where would that intersect my graph?